Alright guys, in this video we're going to be talking about some introduction about the organic compounds, and let's just start out with the organic compounds contains carbon and hydrogen. Alright, and occasionally they will contain halogens. So remember, in the halogens you got fluorine, chlorine, bromine, and iodine. They may also contain nitrogen, sulfur, oxygen, and occasionally phosphorus as well. Um, if I give you some examples, alcohol is an organic compound, and consuming alcohol's formula is C2H5OH. So it does contain one of the oxygens in there. I can talk about sugars. Sugars are going to be C6H12O6. So that's also have the oxygens in there, and that's going to be an organic compound. And you may see halogens in there. You may also see nitrogen, sulfur, oxygen, and phosphorus as well. But it has to have carbon and hydrogen. Now, if you see a compound that in the organic category but only contains carbon and hydrogen, then it's going to be called a hydrocarbon. As the name specify, hydro means hydrogen and carbon means carbon. Alright, and some of the good examples of these hydrocarbons are going to be your alkanes, alkenes, and alkynes. Alright, let's start out with an alkane and the cycloalkanes. A simple formula for an alkane is going to be CnH2n plus 2. So another way of saying how many hydrogens you're going to have in a compound of an alkane is really dependent on how many carbons you have to start out with. So suppose if I have 8 carbons to begin with, alright, so if you have C8, then figure out how many hydrogens you're going to have. Well, if I do 2n plus 2, so it's going to be 8 times 2 plus 2, that's going to be 18. So it's going to be C8H18. And if you guys recall, this is called octane. That's the active ingredient in gasoline. Alright. Alkanes are going to be saturated hydrocarbons. What does that really mean? That it contains only carbon-carbon single bonds. There's not going to be any carbon-carbon double or triple bonds in there. And saturated means you cannot add any more hydrogens onto that molecules. It contains the maximum hydrogens you could have based on the number of carbons. So suppose you have 5 carbons. So if you have 5 carbons, how many hydrogens would you have? Well, do the math here. You need to have 2n plus 2 for the number of hydrogens. So I would do 2 times 5, that's 10, plus 2, that gives you 12. So that's going to be 12 in there, so C5H12. This particular one would be called pentane. We'll talk about the naming in a different session, but right now I just want to give you a brief introduction about these different types of hydrocarbons. Well, in addition to that, you could also have another saturated hydrocarbons called cycloalkanes. Alright, so for the cycloalkanes, I'll probably write that down here. Your cycloalkanes has a different formula. It's going to have a 1 ring present in there. At least 1 ring, you could say. You could have more than 1. And their generic formula is going to be CnH2n. Alright, and they're still going to have carbon-carbon single bonds. They're still going to be called saturated, but they're just going to have 1 ring in there, and due to that 1 ring, they're going to have a shortage of 2 carbons than what you see in case of alkanes. Alright, so know their generic formulas, and obviously generic formulas work when you have only like 1 ring. Like if you have multiple rings, then the CnH2n may not necessarily work in that case. Okay, so then let's talk about the second types of hydrocarbons, which are going to be alkenes, alkynes, and aromatics. Alright, so the alkenes, alkynes especially, and aromatics is a different class, and they behave a little bit differently than the normal alkenes and alkynes, but they're all going to be considered unsaturated. Alright, so what does that really mean? They don't really have the maximum number of hydrogens you could possibly have based on the number of carbons. So you could add hydrogens onto those molecules. All right, so when you eat something and you're not full, you are unsaturated at that particular time. But once you are full, you are called saturated, and then you cannot eat any more food after that. So same story, alkanes are like, consider yourself as alkanes when you are full, but when you're not full, then you can compare yourself to alkenes and alkynes because you can still eat some more stuff. Okay, so let's talk about first alkene. So I gotta write this down here. Okay, so the alkene is gonna have at least one double bond. Okay, so when they could have multiple double bonds, but they need to have at least one double bond to be considered an alkene. And the generic formula for the alkene, it's going to be CnH2n. All right, so keep in mind the generic formula for the cycloalkanes and the alkenes is actually the same. And obviously, the big difference is going to be that cycloalkanes are saturated and alkenes are unsaturated. So if they do give you a compound, like suppose I got a compound here that's going to be C4H8, and if they ask you, okay, how would you really classify this compound among the different hydrocarbons? Well, it could very well be in a cycloalkane, and it could very well be an alkene because it fits in that generic formula. So in order to classify that as an alkene or a cycloalkane, they would have to give you a little bit more information. For example, they could tell you, okay, this compound C4H8 is unsaturated. All right, so that gives you an idea that it's going to be an alkene. All right, suppose if you have 10 carbons, and if you're trying to put this into the alkene, so 10 carbons, how many hydrogens would you have in that case? Well, it's just going to be doubled up. It's going to have 20 hydrogens in that case. Okay, so this generic formula works only when you have one double bond, as it says it's a generic formula. If you have multiple double bonds, then you gotta get rid of more hydrogens. Let's talk about alkynes. So in alkynes, you're gonna have at least one triple bond between the carbons. All right, so you're gonna have a carbon-carbon triple bond. In case of alkynes, you would have at least one carbon-carbon double bond. Okay, so the generic formula for the alkynes is going to be CnH2n minus 2. So you're going to have to subtract the number of twice the number of hydrogens from the carbons and then subtract 2 from there. So for example, if I have 6 carbons, how many hydrogens would you need to have there to make it an alkyne? Well, do your math here and see if that matches up with mine. So I got 6 times 2, that's going to be 12, minus 2, that's going to be 10. So it's going to be C4H10. Okay, I can talk about, let's say I have 2 carbons. If I have 2 carbons, how many maximum hydrogens you should have in order to put this in the category of an alkyne? Well, the maximum 2 times 2 is going to be 4 for the hydrogens, and minus 2 is going to give you 2 hydrogens there. Okay, so C2H2. So your smallest alkene that you're going to have is going to be with 2 carbons, obviously. You can't really have 1 carbon to make it an alkene or alkyne because you have to have a carbon-carbon double bond, and then you have to have a carbon-carbon triple bond. Okay, so then in addition to that, aromatics, like I said, they are a little bit different compounds, but they are still considered to be unsaturated because they got you can add hydrogens to them. It's not that easy to add hydrogens to them just because of their stability, but they would be a ring, and they will have alternate single bonds and a double or triple bond, mostly the double bond, all right, but it's not only limited to the double bonds, you may have a triple bond in there as well. Okay, so that's all you really want to know for that one, but I can talk about the general structure. A general formula for the aromatics is usually CnHn, but like I said, if you have triple bond, then it could vary in that particular case. But for right now, for the hydrocarbons, you categorize into an alkane, cycloalkanes, to be able to identify those alkenes and alkynes and know your aromatics as well, because they're going to have an alternate single and double bond. Now, obviously, you'll learn more about aromatics in different sections because they do behave differently than the alkynes and the alkenes based on the type of reactions they can undergo.